Hello. In this video, we're going to go ahead and graph the quadratic function following the steps in the previous video. So we're going to go ahead and just go through those steps one at a time. And the first step was to determine whether the function opens up or down. To figure that out, we look at the function f of x, and it's equal to x squared minus 2x minus 3. So to figure this out, we want to look at the leading coefficient, and we mean, first of all, the powers have to be descending, which means degree 2, degree 1, and degree 0 there. So looking at the degree 2 term, what's the coefficient? Well, the coefficient in front of x squared is understood in this case as 1. But notice that 1 is positive, therefore this function is opening up. That's important. Okay, number 2. The second step is to find the vertex. But what we mean by finding the vertex is to find the h value, but the h value is just negative b over 2a. So let's find negative b over 2a. In this function, a is 1, b is negative 2, c is negative 3. And let's just plug those into this formula. Negative 2 is plugged in here, and that's going to give me opposite of negative 2 over 2 times the a, which is 1. And then just simplify. Negative 2, opposite of negative 2 is positive 2, so the numerator is going to be positive 2. In the denominator, it's 1 times 2, or 2 times 1, which is 2. And of course, 2 divided by 2 is 1. Awesome. So that means that the x-coordinate of the vertex is 1. To find the y-coordinate of the vertex, we need to find f of that x-coordinate, which was 1. So we're going to take this 1, plug it in for all the x's in the original function, and that's going to give us 1 squared minus 2 times 1 minus 3. And then just simplify that. 1 squared is 1, negative 2 times 1 is negative 2, minus 3 is just, well, negative 3. So we have 1 minus 2 minus 3. Add those together, we'll get negative 4. That tells me that f of 1 is equal to negative 4. Therefore, the vertex is the coordinate 1, negative 4. Excellent. Now then, for the third step, determine the equation of the axes of symmetry. So for the axes of symmetry, it's always going to be in the form of x equals a number. And in this case, the number is just the number in the x-coordinate of the vertex, which was just 1. So x equals 1 is our axis of symmetry. And that's it for the axis of symmetry. Step 4 is to find the y-intercept. Basically, we want to find what is f of 0. Plug in 0 for the x's and simplify. So it's going to give us 0 squared minus 2 times 0 minus 3. And then just simplify. 0 squared is 0, negative 2 times 0 is 0, 0, 0, negative 3 is what's left. So all of this is equal to negative 3, so f of 0 equals negative 3. So the y-intercept is the coordinate 0, negative 3. But remember, in my math lab, or my lab math, sorry, it's just going to say negative 3. Just an FYI. Okay. Next, let's go ahead and look at finding the X-intercepts. I'll go ahead and go over here to do that. So for the X-intercepts, should they exist, let's go ahead and plot the vertex. The vertex was 1, negative 4, right 1, down 4. That was 3. And notice that the function is opening up, so it's going to look something like this. Notice that that means that we should go ahead and find the X-intercepts because they will, in fact, exist. So let's do that. In order to do that, we're going to replace the entire f of x with 0. And that's going to give me 0 is equal to, excuse me, wrong color. 0 is equal to x squared minus 2x minus 3. And this is just a quadratic equation. That's it. We've been solving quadratic equations for a while now, and my recommendation is to go ahead and just factor this. So this gives me 0 is equal to the factorization, which gives me x plus a number, x minus a number. What multiplies the 3 and has a difference of 2? Well, that'd be 3 and 1. And since the 2 is negative, the 3 has to be negative, and the 1 has to be positive. Then just set each one equal to 0 and solve. So we get x equals -1 and x equals 3. So the x-intercepts are the coordinates -1, 0 and 3, 0. And again, in my math lab or MyLab Math, I believe it's going to want just -1 and 3 without parentheses or anything like that because these are not technically coordinates. The coordinates are the -1, 0 and the 3, 0. Good deal. Next, number 6 says to plot the points and graph. Let's go ahead and do that. I went ahead and plotted the vertex already. It's right here. Next, let's plot the x-intercepts, and the x-intercepts were -1, 0 and 3, 0. Awesome. Oops. It's a little bit off. There we go. The y-intercept was 0, -3. Good deal. And believe it or not, we can get one more coordinate because let's go ahead and plot the axis of symmetry. And the axis of symmetry is this vertical dotted line here. And since this is an axis of symmetry, if there's a point here, there must be a point right here as well. And then just connect everything with a curve. And there you go. We just plotted our first quadratic function. Excellent. We still have one more step to do though, and that step asks us to find the domain and range using interval notation. So this, what we just did, was step 6 here. And step 7 is going to be, let's use this light green, I don't use that very often. So step 7 is going to be to find the domain and range. Now, the domain is easy. It's -∞ to infinity. It's the range that might change and will change. Notice that the function is opening up, which means it has a low value. It does not have a maximum because it keeps going up to infinity. And so that tells me that we have a comma infinity here. But that also tells me that the low value is going to be what's down here, and that y value is -4. So this -4 is going to be right there using a square bracket. And that is your range. Awesome. We just completed all 7 steps that were listed. And there you go. We are now done with this particular video. I'm going to go ahead and end it here, and I'll see you next time. Have fun, except for one thing I just realized. Let's go ahead and look at what my math lab looks like for this type of question. I'll see you there. Okay, so here's an example of what my math lab is going to look like. It's going to say something in the form of use the vertex and intercepts to sketch the graph of the quadratic function. Give the equation of the parabola's axis of symmetry, and then use the graph to determine the function's domain and range. And the function that we have is f of x equals x squared plus 4x plus 3. Now yours will be different, but this is what I was given. So what I'm going to do is, I've already found the vertex, and the vertex here is -2, -1. -2, -1, so 4, -8, yeah, -2, -1. Good. So what I'm going to do is I'm going to click on the graph, and notice that we're working with quadratics, so you want to click on the parabola tool, and then you want to click on the vertex itself. It's different from earlier graphings where you just always plotted 0, 0 to begin with. We don't want to do that. We just want to plot the vertex, which is -2, -1. Excellent. And then you also want to find any other point on the parabola, and in this case it's going to be -1, 0, which is an X-intercept, or you could have plotted 0, 3. That works as well. So if you plotted 0, 3, notice it's the exact same parabola. And notice that that actually already tells us, it defines what the parabola is. It's fantastic. It makes everything great. So, and that's it. By the way, if you need to edit coordinates, just click that right there, and you can type in fractions if you need to, or anything like that. You need to round to 3 decimals if you need, if you have any radicals or anything like that. I wouldn't recommend doing that. I would just find some point on the curve, but that's fine. Okay, so check your answer, and good job. Fantastic. Now, the axis of symmetry, just type in x equals, and the x coordinate was -2, so just click enter, and that tells you well done, fantastic, outstanding. Now the domain of f is always -∞ to infinity. Nice work. The range, however, notice that it goes down to this y value of -1 and goes up to infinity. So the range starts at -1 and ends at positive infinity. Excellent. Now, in this next one here, notice that the terms are not in the correct order. Make sure you put them in the correct order. So make sure that's -x² plus 6x minus 8, and then just go from there. And the same thing here, just do what we've been doing. This is something that we'll come back to later, but basically it's just an application. The vertex of a parabola is the maximum or the minimum, and that's really what this is going to be talking about. And that's what the rest of this is about. All right. Well, I'm going to go ahead and end it here, and I will see you in the next video. Have fun.